Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing how to convert a hexadecimal number into a decimal number system. So as we all discussed, the hexadecimal number system consists of 16 different digits which is ranging from 0 to 9 and from A to F. In this lecture, we are discussing how to convert back this number into a decimal number system. As we all know, in a decimal number system, the places or the positions are counted as zeros, tens, hundreds, thousand, etc. In a hexadecimal number system, this representation is based on the power of 16. That's a fundamental point we have to know. So the different powers of 16 is representing in the first step itself. So 16 raised to 0 is equivalent to, any number raised to 0 is equivalent to 1. 16 raised to 1 is equal to 16. 16 raised to 2 is equal to 256. And 16 raised to 3 is equal to 4096. And 16 raised to 4, it is equivalent to 65536, and so on. Now, my dear student, consider an example. An example is convert 1AE to the base 16 into its decimal equivalent. So, while converting a hexadecimal number into a decimal number, we have to consider that number 1AE and consider the positional value or the positional representation of each digit in that number. So the position of E is 0. The position of the number A is 1. Of course, the position of 1 will be 2. And if there is another number, that number position will be 3, and so on to the EMSB. So in the second step, what we have to do is consider this number and multiply that number with the positional power of 16. So this number E is equivalent to 14. So the number E will be multiplied with 16 raised to this position power is 0. 16 raised to 0. So the E is equivalent to 14. 14 is multiplied by 16 raised to 0 is equal to 1, which is equal to 14. And in the second step, A is multiplied with 16 with the power of 1. That is, A is equal to 10. 10 into 16 raised to 1 is 16, which is equal to 160. And in the third step, 1 is multiplied with 16 raised to 2, 16 square, which is equal to 1 into 256. That is equal to 256 itself. And finally, add all these numbers. So 256 plus 160 plus 14. 6 plus 4 is 10 with a carry 1, 12, 13. Then 430, 430. So the final answer will be 430 to the base 10. So the hexadecimal number 1AE is equivalent to the decimal number 430. This is how we are representing a hexadecimal number into a decimal number system. So my dear students, consider one more example. Another example is 100F to the base 16. So this number 100F. Here consider the positional powers. The positional power of this F is 0, 1, 2, 3 and 4. Next step we have to consider F. The equivalent of F is 15. 15 is multiplied with 16 raised to 0. 16 raised to 0 is 1. That is 15 into 1. 15 into 1, which is equal to 15 itself. In the second step, this F is equivalent to 15. 15 into 16 raised to 1. That is 15 into 16. 15 into 16 is equivalent to 256. 40, 240. And in the next step, 0 is multiplied with the 16 raised to 2. So any number is multiplied with 0 will result in 0. And in this step, again 0 is multiplied with 16 raised to power 3. Again that results in 0. And in the last step, 1 is multiplied with 16 raised to 4. 16 raised to 4 is 1 into 65536, which is equal to 65536. So in the last step, add all these numbers. That is 65536 plus 240 plus 15. So this will result in 6 plus 5 is 1 with a carry 1, 4, 8 and 9, 7, 5, 6. So the final answer will be 65791 to the base 10. So the hexadecimal number 100FF to the base 16 is equivalent to the decimal number 65791. So my dear students, this is how we are converting a hexadecimal number into a decimal number system. So my dear student, consider one more example. Another example is AFB. The hexadecimal number is AFB. We have to find out the decimal equivalent of this number. The number AFB, the positions are 0, 1 and 2. In the next step, what we have to do is B into 16 raised to 0. B is equivalent to 11. So 11 into 16 raised to 0, which is equal to 11 into 1, which is equal to 11 itself. In the second step, F into 16 raised to 0. F is equal to 15. So 15 into 16 raised to the power is 1. So 16 raised to 1, that is equal to 15 into 16, which is equal to 240. In the third step, A is equivalent to 10. 10 into 16 raised to 2. 16 squares are 256. So 10 into 256, which is equal to 2560. So finally what we have to do is add all these 2560 plus 240 plus 1, that is 1, 11, 8, 2811. That is, the hexadecimal number AFB can be represented in decimal as 2811 to the base 10. So my dear students, hope you had understood this topic. So dear students, kindly go through these assignment questions. The questions are: convert these hexadecimal numbers into its decimal equivalent. The hexadecimal numbers are 10AFB. Second one is 36B9. And third one is FEC1. So dear students, kindly convert these hexadecimal numbers into decimal equivalents. In the upcoming lecture, we will discuss how to convert a floating point hexadecimal number into its decimal equivalent. See you soon. Until then, goodbye. Thank you and all the best.